Hello students, last class we discussed about polymers. Now let us discuss chemistry in everyday life. So chemistry plays important role in our everyday life, starting from morning to night. So the toothpaste you use, the toothbrush, the clothes, the coloring material of our clothes, and different foods, different medicines, all are made of chemicals. So chemistry makes our life comfortable. It increases the longevity of life, etc. So here we are going to discuss three important applications of chemicals, that is chemicals in medicines and chemical in food and chemicals for cleansing agents for cleaning. Okay, so first let us discuss chemicals in medicines. So the chemicals which are used for curative purpose, for prevention of diseases, for curative of for cure of diseases, that are known as your medicines. So that medicines are the chemicals. Medicines are the chemicals which are used for to cure some disease and prevent from disease. Okay, so these are also known as drugs. So drugs are the substances which have low molecular mass, and when it applicable to the macromolecules, it exhibits some biological response. In this way, so due to this biological response, these medicines, these drugs are used for to cure from diseases. So depending upon the therapeutic action of these medicines or drugs, these are classified into different types such as antacids, antihistamines, tranquilizers, analgesics, then antipyretics, anti-fertility drugs, antiseptics, antibiotics, etc. So now let us discuss one by one. Antacids. So antacids, these are the medicines or these are the chemicals which are used to decrease the acidity which are generally used to acidity in case of acidity, or which neutralize the hyperacidity effect of gastric juice. Okay, so some commonly used antacids are magnesium hydroxide, aluminum phosphate, sodium bicarbonate, potassium bicarbonate, and you know that is the Gelusil that contains milk of magnesia or aluminum hydroxide, etc. Then nowadays some antacids used are ranitidine, cimetidine, rabeprazole, etc. So in this same, it maintains the pH level of the gastric juice. If the so it neutralize the excess acid secreted from gastric juice. Okay. Next, antihistamines. So the antihistamines, these are the drugs which decrease the effect of histamines. The histamines produced in the body, which is decreased by the chemicals that are known as your antihistamines. Simply say, these are the medicines which are used for allergy. So for allergic action, what are the medicines used that are known as your antihistamines? So histamines causes different allergies like your nasal congestion and burning of eye and sneezing, etc. So this effect is decreased by these antihistamines. So some commonly used antihistamines are terfenadine, dimetapp, diphenylhydrazine, and phenanthrene, malate, Ravil, Benadryl. These are some examples of antihistamines. Next come to tranquilizer. So these are also known as psychotherapeutic drug. In case of mental diseases, generally these are used. So these affect our central nervous system. So these tranquilizers affect our central nervous system. So these are used in case of mild or severe mental diseases. This also decrease stress. So these are used to decrease stress, and in general these are used in case of mild or severe mental diseases. That's these are also known as psychotherapeutic drug. Some examples of noradrenaline, veronal, amytal, and nembutal, luminal, seconal. So these are the examples of some tranquilizers. Next come to analgesics. So analgesics, these are the medicines or these are the drugs which are used to decrease the body pain. So these are also known as the pain relievers. So the drugs which are used to relieve from pain, to reduce from pain, which gives relief from pain, that are known as your analgesics. So analgesic, these are the drugs which gives relief from pain, and these analgesics without affecting the central nervous system. These analgesics are two types. One is your non-narcotic drugs, another known as your narcotic drugs. So the non-narcotic drugs are your paracetamol, aspirin, ibuprofen, diclofenac sodium or diclofenac potassium, etc. So these are the examples of non-narcotic drugs. And narcotic drugs, that are your morphine, codeine and heroin. So these generally this causes addiction and this do not causes addiction. So both are known as your analgesics. So these analgesics are non-narcotics and these analgesics are narcotics. Next come to antipyretics. So antipyretics, these are the drugs which reduce body temperature in case of fever. So in case of fever, if some drugs are used to decrease the body temperature, that are known as your antipyretics. So these are the drugs which reduce body temperature in case of fever. Some examples are phenaticin, crocin, novalgin, combiflam, etc. So the paracetamol and aspirin, these two are used, both are analgesic as well as antipyretics. So this paracetamol and aspirin, these are used as analgesic as well as antipyretics. Next come to anti-fertility drugs. So these are the drugs generally which controls the pregnancy. Generally used, so these are the drugs which are used in case of to control pregnancy, and these are generally some hormones. Some examples of anti-fertility drugs is norethindrone and ethyl estradiol, novestrol and mifepristone, etc. So these are the examples of anti-fertility drugs. Next come to antimicrobial drugs. So next come to antimicrobial drugs. So the antimicrobial drugs, generally you can say antimicrobials or antimicrobial drugs. So these antimicrobials are the medicines or the chemicals which are used to destroy or check the growth of microorganisms. And these antimicrobials are of three types. One is known as your antiseptic, disinfectant, and another antibiotics. All these are antimicrobials. So antiseptics, these are the chemicals which are used to destroy or to kill, or to check the growth of microorganism, and these are applicable in case of living tissues, in case of wounds and cuts. So some So these are the chemicals which are used to destroy the microorganisms in case of wounds and cuts, and it also inhibit the growth of other microorganisms. And some examples of antiseptic is there are different that is the tincture iodine, iodoform, mercurochrome, hydrogen peroxide in the form of perhydrol, and some dyes like Jensen violet, methylene blue, and some chemicals like boric acid, etc. So these are known as your antiseptic. Next, disinfectant. So disinfectants, these are also the chemicals which destroy the microorganism, but it is not safe for living tissues. Generally, these are used for non-living surfaces. So these are used for non-living surfaces, and antiseptics, these are used for living tissues. Both are used to destroy. So these are both antiseptic and disinfectant. Generally, these are used to destroy the microorganism developed on surfaces, different surfaces. But these antiseptics, these are used for living tissues, so for living system, and these are used for non-living systems. For generally, these are used to clean the urinals, drains, etc. Have different surfaces, table, floor. So these are disinfectants used to destroy the microorganism developed on floors, different table surfaces, as well as drains, urinals, etc. But antiseptics, these are used for generally living systems or living tissues. And same substance can act as disinfectant as well as antiseptic. Same substance can act as disinfectant or antiseptic depending on its concentration. For example, 1% of phenol is acts as disinfectant, whereas 0.2% of phenol 0.2% of phenol acts as antiseptic. Similarly, some other disinfectants are phenyl, Dettol, Savlon. So these are also some examples of Dettol, phenyl. These are some examples of disinfectants. Next, come to another antimicrobial that are known as your antibiotics. So antibiotics, these are the chemicals derived from one type of microorganism and that destroy another type of destroy or check the growth of another type of microorganism which are injurious to our health. So antibiotics, these are developed from, these are the chemicals which are derived from one type of microorganism and that kill or that check, either that kill or that check the growth of another microorganism which are injurious to health. So all these are known as your antimicrobials. Next, these antibiotics again classified into two types depending on its action towards bacteria. Antibiotics classified into two types depending on its action towards bacteria. One is known as your bactericide, another bacteriostatic. So bactericides, so these are the antibiotics which kill the microorganisms. So which kills the microorganisms introduced to health, known as bactericide, but which check the growth of other microorganisms, that are known as your bacteriostatic. So this kill and this check the growth. So it check the growth or control, inhibit the growth, inhibit or check the growth, and these kills or destroyed. So the antibiotics which kills or destroys the other microorganisms injurious to health are known as your bactericide antibiotics, and which inhibit or check the growth of other microorganisms that are injurious to health are known as your bacteriostatic antibiotics. So some bactericide antibiotics are penicillin, aminoglycosides, ofloxacin. So these are the examples of, these three are the example of bactericide antibiotics. Whereas tetracycline, erythromycin, chloramphenicol, oxytetracycline, these are the example of bacteriostatic antibiotics. And these antibiotics again classified into two types depending upon its action towards the range of microorganisms. So the application, this is known as your spectrum of antibiotics. This is classified into two types. One is known as your broad spectrum antibiotics. Broad spectrum antibiotics, another narrow spectrum antibiotics. So broad spectrum antibiotics, these are the antibiotics which are used over a long range of microorganisms. Depending upon the range, these are classified into two types, broad spectrum and narrow spectrum. The antibiotic which are used for different diseases or towards a long range of microorganisms, that are known as your broad spectrum antibiotics. So these are applicable to both gram positive and gram negative bacteria. And narrow spectrum antibiotics, these are the antibiotics which are used up to a limited range of microorganisms. So limited range of microorganisms, that are known as your narrow spectrum antibiotics. So this is a long range of microorganisms. This is applicable to a narrow range, a limited range of microorganisms. So this is applicable to both gram positive and gram negative bacteria, but this is applicable to either gram positive or gram negative bacteria. So some examples of broad spectrum antibiotics what are given underlined here: ofloxacin, tetracycline, erythromycin, chloramphenicol and oxytetracycline. All these are the examples of some broad spectrum antibiotics. So chloramphenicol is a broad spectrum antibiotics. Tetracycline is a broad spectrum antibiotics. Whereas penicillin and aminoglycosides, these are narrow spectrum antibiotics. So this is little knowledge about chemistry in everyday life. This is a brief knowledge about chemistry in medicines. So this is a brief knowledge about chemistry in medicines. Next come to another part, that is chemistry in food or chemicals in food. Now next come to application of chemicals in food. chemicals in food. So some chemicals are also used in food to enhance its look, that is its appearance, and to increase its taste. So appearance, look, taste, and lifetime of food, to increase the lifetime of food. So some chemicals are used to increase its appearance, look, taste, and lifetime of food. That are some chemicals. So for its appearance, some color are used. For increase its flavor, some flavoring agents are used. Similarly, to increase its taste, some artificial sweeteners are used. So to increase taste, that are artificial sweetening agent. Artificial sweetening agent. So generally, for to increase the sweetness of any substance, generally we are using sugar, that is the sucrose. And this is a carbohydrate, and intake of this sucrose increase the obesity, it increase the calorie value, in this way it increase the obesity and also causes tooth decay. In this way, to decrease the harmful effect of this sucrose or this sugar, some artificial sweetening agents are used. The first used artificial sweetening agent is saccharin. So saccharin, and nowadays some different artificial sweetening agents are used, such as aspartame, aspartame, sucralose, L-glucose, etc. So these are some artificial sweetening agent, and the saccharin has 200 times more sweetness as that of sucrose. It has 500 times more sweetness than that of sucrose. This has 200 times more than that of sucrose. So in this way, these are actually these four are saccharin, aspartame, aspartame, and sucralose. Actually, these are non-carbohydrate sweetening agents, and L-glucose is also a carbohydrate sweetening agent, but this is not affected by enzymes and can be used for sweetening different food. Okay. Next come to the chemicals which are used for food preservatives. Then food preservatives. So food preservatives, these are the chemicals which are used in food. It increases the lifetime of food. It destroys it checks or destroys the fermentation of food, or it destroys the fermentation of food, acidification of food. So these are the chemicals which are used to decrease the fermentation, acidification, and growth of microorganisms, growth of microbes like fungi, yeast, molds, etc. So these are the chemicals which decrease the fermentation or acidification of food, and this decrease the growth of microbes, that is fungi, yeast, molds, etc. These are known as your food preservatives. Some commonly used food preservatives are benzoic acid in the form of sodium benzoate, sulfur dioxide in the form of potassium metabisulfite, or sodium metabisulfite. So sodium or potassium metabisulfite, sodium or potassium metabisulfite, sodium benzoate, vinegar, citric acid, etc. So these are food preservatives. In ancient times, generally we are using sodium chloride, that is the table salt, sugar. So table salt, sugar, oil, these are also used as food preservatives. Okay. So for preserving mango, generally sodium chloride is used. In some cases, generally sugar is used. So sugar, sodium chloride, traditionally used food preservatives, and some chemicals used for food preservatives such as sulfur dioxide in the form of sodium or potassium metabisulfite, sodium benzoate, vinegar, citric acids. These are the examples of some food preservatives. Next come to another type of chemicals that are used in food, that are known as your antioxidants. Antioxidants. So antioxidants, these are the chemicals which generally used to check the oxidation of food or the acidification of food. So this checks the acidification or oxidation of food, that are known as your antioxidants. Some commonly used antioxidants are BHT, butylated hydroxytoluene, butylated hydroxytoluene, and BHA, butylated hydroxyanisole. These are some commonly used antioxidants. And vitamins, vitamin E, vitamin C, citric acid, these are also used. These are also vitamin E, vitamin C, and citric acid. They are also used as antioxidants. So antioxidants, it also increases the lifetime of food. It decreases the formation of free radical. So decrease the acidification, oxidation of food, and formation of free radicals. So these are known as your antioxidants. So these are some examples of chemicals that are used in food. Next come to chemicals that are used for cleaning properties, that are known as your cleansing agents. cleansing agents. So chemicals that are used to clean clothes or different surfaces are known as your cleansing agents, and these cleansing agents are also known as surface active agents. Surface active agents or surfactants or surfactants. So there are two types of cleansing agents. One is generally known as soap, another known as detergent. Soap, another detergent. So what are soap? Soaps are generally sodium salt of long chain carboxylic acids. These are sodium salt of long chain carboxylic acid. Okay, so the long chain carboxylic acids, sodium salts of long chain carboxylic acids, these are known as the soap, and generally these are derived by the hydrolysis or saponification of oils and fats. These are generally formed by the saponification of oils and natural oils and fats. And these soaps are, for example, if these oils and fats are triglycerides of higher carboxylic acids. So soap are sodium salt of higher fatty acids. Soaps are sodium salt of higher fatty acids. The process by which soap is prepared from oil and fat is known as saponification, and oil and fats are triglycerides of higher carboxylic acids. For example, so this is one oil, and when this is hydrolyzed in presence of sodium hydroxide, that is alkali, it undergo hydrolysis to form glycerol plus. So, glycerol plus soap. So, this is soap. Okay. So, these soaps are different types. So, if this is hydrolysis generally takes place by sodium hydroxide. This is known as your sodium salt of the soap, and generally these are used for washing purposes, and these are hard soap. And if this hydrolysis takes place in place of sodium hydroxide, if it takes place hydrolysis in presence of potassium hydroxide, these are used known as soft soap, and these are used as toilet soaps or for bathing. Okay. Next, soaps are different types, different fillers, color, perfume, etc. are added to the soap to form different types of soap. For the formation of transparent soap, the soap is generally dissolved in alcohol, and the extra solvent is evaporated. In this way, transparent soaps are formed. So soaps are generally? The soaps are generally sodium salts of higher carboxylic acids, long chain carboxylic acids. These are known as your soap. And what are the detergents? So detergents are long chain. So these are also the sodium salt of long chain alkyl sulfonates or alkyl benzene sulfonic acids. So detergents are sodium salt of higher or long chain sodium salt of long chain alkyl sulfonates or sodium salt of alkyl benzene sulfonic acids. For example, CH3, CH2, 10, CO, OSO3, Na. So this is known as a detergent. Okay, long chain alkyl sodium salt of long chain alkyl sulfonates or benzene sulfonates. So these are known as your detergents. Detergents are classified into three types: cationic detergent, anionic detergent and non-ionic detergent. So the cationic detergents are detergents. Generally these are quaternary salt of ammonium. These are the quaternary salts of ammoniums, amines, quaternary salts of amines. For example, and the anionic part is either bromide, chloride, like this. So these are the amines, quaternary salt of amines. These are known as your cationic detergent. Here the cation part is the hydrophobic part and the anion part is hydrophilic part. This is cationic detergent. Cationic detergent. Similarly, anionic detergent. So these are anionic detergent. The long chain part or the hydrophobic part is anion. If the hydrophobic part or the long chain part is an anion, this is known as anionic detergent. If the long chain part or hydrophobic part is a cation, this is known as just cationic detergent. And non-ionic detergents, these are generally formed from alcohols and acids. These are generally formed from alcohols and acids. So there is no cation part and anion part. There is no cation part and anion part. And generally it has ester linkage. These are some esters. Generally the liquid dishwash are made of this non-ionic detergents. Then what is the difference between the soap and detergents? So the difference between soap and detergents is that these are formed from natural oils and fats. So these are formed from natural oil and fats, and these are formed from petroleum product. These are formed from petroleum product. Next, soaps are insoluble in calcium and magnesium salts of water. Aqueous solution of calcium and magnesium salts. Soaps are insoluble in calcium and magnesium, aqueous solution of calcium and magnesium salt, or calcium and magnesium salts dissolved in water. In this way, soaps cannot be used in hard water. This can be used in hard water, but detergents can be used in hard water because these are soluble in aqueous solution of calcium and magnesium salt. Next, this soap cannot be used in acidic solution because it undergo hydrolysis And detergents, as generally it contains the acidic group, strong acidic group, that is sulfonic acid or sulfuric acid, strong acidic group. This can be used. Acidic solution, it can't be used. And this can be used in acidic solution. Detergents can be used in acidic solution, but soaps can be used in acidic solution. Next, soaps are generally biodegradable, and in this way it causes no water pollution. No water pollution. Maximum detergents are non-biodegradable. In this way it causes water pollution. Okay. So these are formed from natural oils and fats. These are generally formed from petroleum product. These cannot be used in hard water. These can be used in hard water. Soaps cannot be used in acidic solution. Detergents can be used in acidic solution. Soaps are biodegradable, so causes no water pollution. Detergents are maximum detergents. Some detergents are also biodegradable. Maximum detergents are non-biodegradable and causes water pollution. Okay. So this is some idea about chemistry in everyday life.